In part two of our ways to solve proportions, this video will go much faster because we don't have to do as many reminders about different things. But this second way is called outer rainbows. We know inner rainbows, we've seen a little bit of outer rainbows. Again, we're looking for a common multiplier, this time between two different ratios rather than within one ratio. So let's take a look at outer rainbows. Again, up until the third different change in screen, you don't have to write anything down. Just watch me through my examples and jot some examples in your notebooks. So, outer. Remember, what we're used to with ratios is with the tables and how we can see those connections inside with those rainbows. So here again, when we know with proportions, they're going to be just two different ratios, and then one number is going to be missing. So if I go with 4/7 is equal to blank, let's go 40 seconds. What I'm going to look for now is, instead of seeing a whole number multiplier between 4 and 7, I'm going to use between the two numbers that are on the bottom of both ratios to help me. And so now I'm looking to see, okay, does 7 go evenly into 42? And in this case it does by multiplying by 6. Because I know that these two are proportional and equal to each other, they have to have those same multipliers, meaning that I can take that number 4 multiplied by that same number 6 to end at 24 40-seconds as my equivalent and proportional ratio. So what's different now is that we're looking outside of the ratio to find out those scale factors and multipliers. Here's where I'd like you to write down some different things in your examples and your notes, some different ways to solve. So here we're going to see two different problems that don't have any common or whole inner rainbows that allow us any kind of good multiplicative connections. So now we're going to use this idea about outer rainbows, connecting the two numbers that we know, not the two ones that we don't, but the two known numbers, to see if there's any multipliers. In this top one, I can see that 8 times 8 is equal to 64. So I have to take 9 times 8 to find my final answer. So in this case, I'm going to get 64 70-seconds as my final answer in this case. In this bottom example, I'm going to see that I have blank sixths is equal to 12 18ths. Again, 12 doesn't have any whole number multiplying connection to 18, so I'm going to look between this 6 and this 18. And since I know both of these numbers and I need to move in this left direction, I'm going to be looking for what I need to do from 18 to get to 6. And so in this case, I need to divide by 3. Divide by 3. And if I take 12 and divide it by 3, I'm going to end up with my number. And that number is going to be 4. I can't go multiplying one way because I have nothing to multiply by 3 to equal 12. If you want to think about that and think about blank times 3 equals 12, that's another way we can solve. But in this case, division seems to work a little bit easier. And lastly, same as with the last one, we can do this even if there isn't a whole number scale factor. So if I give you just 3 random numbers and put them into two different ratios, something like 4/9 is equal to 13 blanks, I see really no connection in anything with inner rainbows between the 4 and the 9 or outer rainbows between the 4 and the 13. So if I want you to try to solve that, again, you can use this method and this can work, but you have to use your decimal division in order to help you. So now to solve this one, I want to figure out what 4 times something equals 13. And to do that, I think those fact families, and 13 divided by 4 will give me that answer. And when I punch that through in my calculator, 13 divided by 4, I get 3.25. And so that means I know that there's a multiplier here of 3.25. Because of that, I can use my outer rainbow method and multiply 9 times 3.25 and end up with a grand total of 29.25. So I can use this method with things that don't have whole number scale factors, but it just works out really, really well if you can see those things easier and it kind of goes a little bit faster. So the next method we're going to show is when, and especially you can use cases like this where you don't have to do as much back and forth. So when you see things that don't have inner rainbows or outer rainbows, how you can still figure those out. We have one more video to go through and then we are set.